Very good. So, welcome to our session today, everyone, on transforming environmental air quality monitoring with IoT and Power Platform. Today, Tim Hanowich, our speaker, will dive into how to leverage the Power Platform alongside IoT devices for real-time environmental air quality monitoring. This is just one use case where state and local governments can leverage integrating IoT data via Power Automate into Dataverse with Power Apps at the app layer, and then leverage Power FX and Power BI to report and visualize and provide insights for an organization to act on that data. So as Tim's presenting today, think about the possibilities for your organization and leveraging the same components to support a use case within your department or agency. Perhaps it's in waste management or traffic monitoring. Maybe you need to monitor temperatures in buildings or other infrastructure. Maybe you want to monitor parking availability in public parking places. So think about the different ways that you could leverage the same possibility or components, right, into a solution. So today we aim to provide a digital event that respects all individuals. So we ask that everyone provide a safe and welcoming environment for everyone. We do bring 3 of these events to our customers each month, always on Thursdays at 2 p.m. Eastern Time. If you have a topic that you would like us to present on in the future, go ahead and drop that in the chat, and we will get that in for consideration in our schedule. To minimize any distractions or potential background noise today, we do have everyone muted. So use a chat for questions during the presentation. And if we have time at the end, we'll go ahead and open up those mics for live questions as well. And additionally, we will send an email after the session today. Well, actually, it'll go out tomorrow with the recording and the deck that's being used by Tim today. If you don't want to be included in those emails in the future, go ahead and just reply back to me and I'll take you off that distribution list. So with that, I am going to hand it over to Tim to get started. Thank you so much, Tim, bringing this great topic to our customers today. Thank you so much.
Thank you, Deb. I'm very happy to. And thank you all, first of all, for you being here today. I am pumped for today. We're going to show off a very cool use case in the Power Platform that spans really almost the entire Power Platform, right? From Power Automate to Dataverse to Power Apps and Power BI, but also incorporate IoT devices. And of course, that use case will be environmental air quality monitoring. But keep in mind, as I mentioned earlier, there are probably plenty of SLG use cases for collecting and monitoring and tracking telemetry out in the environment somewhere, whether it be a parking lot or a bridge or a building or the environmental air quality, of course. So I thought first today it would be best to start with the question of what is air quality? Simply put, air quality is just a measure of how clean the air around us is. And air quality is important for everything that we do, from human health and well-being to crop health, and even today to the environment health, right? The health of plants, animals, and the overall broader ecosystem. But really, air cleanliness is usually described as a concentration of air pollutants in the air, in a certain quantity of air, that is. And of course, today, there are sort of 2 main sources of air pollution. There's the first one we hear about very commonly, human-caused air pollution sources. For example, manufacturing, vehicle exhaust too, right? Buses and cars, etc. But also agriculture. You know, today in 2024, there are so many pesticides being used, which of course are hurtful to the environment. And also airplane jet engines are notoriously bad for the environment as well. There's also, not only though is pollution caused by humans, but there's also pollution to the air caused by natural sources, right? The main one we probably hear of a lot nowadays, especially in the west coast of the US and also in Hawaii recently, are wildfires. The burning of biomass, leaves, trees, etc., can be very bad for the air quality, as can volcanoes. In fact, when a volcano erupts, typically for up to a month or even more than that, you have poor air quality in a radius of about 100 miles or so. Also, dust storms are bad, as is pollen. And I'm sure people on the call today who have an allergy to pollen will also agree with me that pollen can also be very bad for the air quality. So now that we know what air quality is, how do we measure air quality? Well, again, air quality is simply usually expressed in a concentration of pollutants in the air. And when I say pollutants, chemically speaking, these are compounds like, for example, terpenoids, which are found in pollen or other natural growths, formaldehyde, which are found oftentimes in plywood and also in plastic manufacturing. Also, we have nitrogen oxide, which is commonly found in exhaust from jets or from cars, and methane coming from the burning of biomass or trees or leaves, etc. But really, all of these and more are classified into what we call today volatile organic compounds, which is simply a term that means that these are compounds in the air which are not healthy for humans or other animals to breathe in, or for that matter, for the overall ecosystem. Now, why is it important for state and local government to track and monitor VOCs in the atmosphere and in the broader ecosystem? Well, as a government, one of the sort of core pillars of government, sort of one of the core missions there, of course, is to look after the safety and well-being of its people. And so, first of all, air quality can have massive effects on people's health. First of all, breathing in pollutants can absolutely cause irritation, right? Coughing, wheezing, shortness of breath, or even cause stuff like bronchitis. And this is especially dangerous for people with asthma, of which, by the way, there are 25 million people with asthma across the US today. Um, while for older people, this might be more of an irritant, studies have shown that having poor air can absolutely lead to very serious and very significant effects on development in children, for example, in their lung capacity and whatnot. Not only is human health important for government, but also environmental protection is also extremely important and a main pillar as well of government. Now you might ask, how can pollutants in the air affect the environment? It's actually sort of interesting here, but what happens is the air is polluted and then rainfall happens, and during rainfall, that rain will collect the pollutants into each droplet, which will then of course land in either a forest or trees, but more commonly a lake, a river, or a stream, where that pollution, those chemicals will then seep into the soil, poison the soil, and then poison crops nearby, which will of course eliminate a food source for animals and affect the entire food chain from there. So it's very important as well for the environment to monitor and track air quality. And then thirdly, also a major pillar of government, to look after the economy, of course. And air being polluted can also have massive effects on healthcare costs. I mentioned earlier that in the youth, typically bad air causes irritation, coughing, and so forth. But in the older population, it can absolutely cause anything from bronchitis to even cancer, for example, happening in the lungs. Also, poor air can absolutely affect crop yields, which is very important to the economy and areas where they rely on crop yields. And thirdly, with poor air, maybe for example in a city area, there will absolutely be an effort to purify the air but in people's homes, and that will absolutely affect the energy demand in the area. So for these reasons, health, environment, and economy, what happened was the US federal government in 1963 started, or they passed the Clean Air Act, which established what's called the National Ambient Air Quality Standards, which essentially state that states have to establish, well, number one, have to establish air quality monitoring networks to track air quality. They have to establish limits on how poor the air can be. They have to develop and submit their own plan to ensure that they will enforce these rules. And then finally, enforce these rules on businesses and people that do violate these in the form of penalties and so forth. And so from a national perspective, air quality is a very important part of government. So today, of course, we're going to show how we can track and monitor air quality in a Power Platform-based solution. So what I'll do today, first of all, is I'll walk you through here a very high-level overview of what I'll build today and what I'll show you today. I'll just simply speak to what I built and how I built it. Then later on, I'll go to my actual Power Platform environment and show you live how I built what I did. First of all, this solution today is fully open source on GitHub. And in fact, I want to show you here, if you just go to a new tab and enter in aka.ms/slg biz it'll bring you here to our GitHub repo, specifically for SLG and biz apps. Go to demos, and under the environmental air quality folder, we have the entire solution there. We have photos, descriptions, and the entire solution and source code as well for this project. So please do leverage this if you want to. But moving on here, I'll sort of again walk through how I built this solution step by step, piece by piece, before I go into an actual deeper demo of the actual software. So first of all, to have a way of tracking environmental air quality, we have to have a sensor system out in the environment. So we have to have essentially an IoT device out there that's continuously recording and tracking the air quality. So for my project, I chose to use a Raspberry Pi Pico W, $5, $6 microcontroller, and I paired that with an ENS 160 air quality sensor to allow me to monitor and read the ambient volatile organic compounds in the air surrounding it. Also, I threw in a DHT22 sensor to track the temperature and humidity. I took these three, put them together, and I placed them into my own 3D printed housing, put a lid on that, and I taped that to the outside of my home here in Florida, on the west coast of Florida. So just to track the sort of conditions outside of my home here in Florida. Now, on that Raspberry Pi, I wrote a very lightweight Python script to once per minute record that data from the sensors, 3 data fields from the ENS 160. The first one, of course, being air quality index, a number between 1 and 5. 1 would be the best quality air, 5 would be the worst. Total volatile organic compounds, or TVOC for short, essentially the sum of the VOCs in the area, pollutants and whatnot, and then the equivalent carbon dioxide. In other words, a rough estimate for how much CO2 might be in the area currently. So I get 3 fields from the ENS 160, I get 2 from the DHT22, the temperature and the relative humidity. Now, of course, after my script takes that data, it needs a place to live. So I opened up in Power Platform a new Dataverse table directly mirroring my data. So a new table I have here called air quality reading with 5 fields in it, 3 for the ENS 160 and 2 for the DHT22. Now, how can I get data from my Raspberry Pi, my device, to Dataverse? And the answer today, I'll show you later on, is of course through a Power Automate workflow. I have my own Power Automate workflow built, established, and my workflow's trigger is the trigger when an HTTP request is received. So what'll happen is my Raspberry Pi will, again, once per minute, record data from the sensors, and then take that data as a JSON body and perform an HTTP post request to my Power Automate, which will in turn take that data, parse it, and insert that as a new row into my air quality reading data or table in Dataverse. Now with that data in Dataverse, I'm now able to very easily show it here in a Power BI report. Power BI is a really great integration with Dataverse, show data very easily. So I'm able to very quickly call to Dataverse and pull in data into a report or a dashboard here. I can then publish that to the cloud, then take that report and embed that into a Power App. So in my Power App dashboard, I will have not only a Power BI report, but also on the right there, sort of a peripheral view showing me my most recent, my current, if you will, temperature, humidity, and my current air quality. Finally, now at the very end, you might ask, well, how can we provide this data to the public? How can we allow, for example, developers to call to our system to pull out data? And for that, again, I will call here on Power Automate, and we'll have our own Power Automate workflow, which will again be triggered upon an HTTP call being made, this time a GET request. In my Power Automate flow, after it's triggered, I'll then query Dataverse, pull in that data, and then structure that as a response in JSON to the caller, essentially creating sort of like a makeshift API system here in Power Automate. So that's my system. Of course, I only have one out there outside of my home right now, but ideally you'd probably want to have multiple, maybe them, for example, spread out across an entire county or entire state's area. Before I go to my demo though, actually in Power Platform, I do have a confession to make. And that confession is recently, if you know sort of the southeast area of the country, if you live there at all, you've probably known that we had recently what was originally Tropical Storm Debbie come, which was later, of course, called Hurricane Debbie. But I live sort of in the Tampa area, and I saw this coming, and I thought to myself, what a great way to test out my sensor system. I'll see over time temperature fall as the rain comes, humidity rise, and maybe air quality change. So I thought, fantastic. And so landfall was on August 4th. And I've lived through a few tropical storms here. I have never seen one this bad before. On the right, there's a picture outside of my bedroom window. It was a lot of rain. A lot of rain came in very quickly too. I think we got about 18 inches of rain, which is a lot for here, of course. So I was in here like a nerd, on my computer, slowly in Power BI, watching the conditions change. And I saw over time humidity go up 25% in about 5 hours or so. And then it just stopped suddenly. Like it just stopped working entirely. And also very oddly, hours before that, it had a very, very, very weird reading spike in everything from temperature, humidity, etc. So I thought, what was that? But the truth was, I knew what it was because it's happened to me before. So what happened was, I think Hurricane Debbie killed my Raspberry Pi. It only lived for about a week or so, maybe less than that too. But what I think happened was the moisture came and I gave power to my Raspberry Pi through the USB port. And in a small USB, those prongs are so close together. So I think water vapor came into them. It caused a short between power and ground. It fried my Raspberry Pi. I tested it, it was dead. But the good news was the sensors did still work. So my both air quality and temperature sensor both worked just fine. So I did salvage those. But my confession is I did make a new one, but that new one now is living in my living room, not outside. So I know today we're showing off environmental air quality, but I wanted to be sure that did not happen again before today's demo. So this new one lives in my living room. And until I have a waterproof design for my new sensor, my new sensor package, it'll stay inside where it's dry, clean, behind my TV and my Xbox. So that's my confession for today. But again, we'll pretend for today it's actually outside. So with that being done, why don't we now transition to a live demo of my system? I'm going to close now out of PowerPoint. I'm going to turn off my camera as well. I'm going to share a different screen. All right, so here my plan today is to sort of give you a tour of what I built actually now in Power Platform. So I'll start first, of course, with the place that my data will live. And of course, this is probably paramount to any solution digitally, whether it's on SQL or NoSQL or Power Platform for that matter. But of course, here I have a table made called Air Quality Reading. And in my table, which I'll zoom in here as well, I have the 5 key fields that I'll record from my sensor package. I have, first of all, humidity. I have temperature in Fahrenheit. I have the air quality index, which is, again, is a number between 1 and 5. 1 would be sort of your best air quality. 5 would be your worst. I have equivalent CO2, and I have, very importantly, total volatile organic compounds, or in other words, an estimation for the concentration of VOCs in my immediate area. So now with a place for my data to live, I want to show you how I have an endpoint where my Raspberry Pi can call to put data into this table here. So first of all, I'll sort of walk you through the way that we make them, or the way that we make the actual Power Automate flow. Again, the trigger is excuse me, the trigger is an HTTP call. So I'll hit create over here. I'll go to automated. Skip this for right now. And you may have not seen it before, but there's actually an HTTP trigger to a Power Automate workflow. So it's called a request. And the trigger can be when an HTTP call is received. Click on that, and all it asks me to do is it asks me to give it a sample payload for what the data should look like. So I know for certain when my Raspberry Pi does upload data to Power Automate, to Power Platform, I know that the payload will look a lot like this. Temperature, floating point number, humidity, floating point number, AQI, air quality index, by the way, integer, TVOC, integer, ECO2, integer. So that's my payload. I then give it a sample payload. I hit done. I don't know why it's not letting me save this now. Oh, I think I leaving space maybe. Okay, give me just one moment. I don't know, I might be missing I don't know what's doing that, but regardless though, what you do to create your trigger is you just simply provide to it a payload. And what'll happen is after you do that, this is my existing workflow right here. You'll see here that my trigger here is a HTTP call being made to it. I have it set to a post request, and it'll give me an actual URL endpoint that I can call to from any device to call to this endpoint right here and trigger it. So basically what's happening here, again, my Raspberry Pi records data from the sensors. It then takes that data and performs a post request to this endpoint here, which takes the body as the data, parses that as JSON, and then simply inserts a new row into Dataverse to the proper table, and then plugs in each recording incrementally, one by one, AQI, ECO2, humidity, temperature, and TVOC. So that's how I have a Power Automate based endpoint I can call to from my sensor package to upload data into it. So now that we have the Power Automate workflow created, why don't I go now to show you the actual source code on my Raspberry Pi that performs this process, just to show you that behind the scenes bit of it. So of course here I have my my SLG BizApps GitHub repo cloned and open in VS Code. I can open up the code to this in the environmental air quality monitoring folder, and all of my source code lives, for the Raspberry Pi that is, lives in this SRC folder here. 3 Python modules, and all of the sort of process happens in the main.py module. So I won't walk you through the actual source code very deeply, but it goes through some stuff like, for example, connect to the Wi-Fi system using your password and your SSID, set up each sensor from the DHT22 to the ENS160, and towards the end here, it enters an infinite loop where it first of all ensures that it's still on the Wi-Fi. It then opens a new blank body object, and then it records data from the DHT22, recording temperature and humidity. If it finds that from the sensor, it then plugs that into the body, and then after that, it'll then record the same data, or excuse me, different data from a different sensor via the ENS 160 here, plugging, of course, into the body, the AQI, TVOC, and ECO2. Finally, at the end, if it was successful in getting data from the sensors, it then performs an HTTP call to Power Automate, thus uploading the data to Power Automate. So I have here, if we have data, to put in it, first of all, put it in a try bracket, upload to this post URL here in settings. So ideally here, before you deploy it, this is where you would enter in the URL from Power Automate, where you would want it to perform the post request to. So it just simply takes the data, performs a post request, and then based upon the response from the API endpoint, it'll then print out a different message. For example, it might say, for example, it failed, it did not work properly, or count it as a successful upload of data. And then it just waits for about 1 minute. So that is all it does over and over again. Again, connect to Wi-Fi up here, record temperature and humidity, and then record air quality index, TVOC, and carbon dioxide, and then perform an upload to Power Automate here, and then wait and do it again all over again. And that's been going now for about a week or so quite some time. And I now have a lot of data here in Dataverse to show you. So let me actually go here to Power Platform. And now with data in Dataverse, the easiest way to show that data is a model-driven app. So I have here an app, which I'll refresh here, and this will just simply show me a list of my existing air quality readings sorted by the created on date. So these are showing me here for each minute that I have so far surpassed. It shows me each reading. So I can see here, for example, the most recent one here, 1 minute ago. I can pull it up and see the values from my sensors that were, again, uploaded via Power Automate, showing me my temperature in Fahrenheit, my relative humidity, my air quality index. Again, 1 is the best air quality here inside my home, TVOC, and then equivalent carbon dioxide. Now you also see here that there's another field here called absolute humidity. And you might say, well, how is this different than relative humidity? And the answer is they're actually very, very different. Let me show this slide here actually. Again, the DHT22 provides to me 2 fields, temperature and relative humidity. Now, relative humidity is a measure of the amount of water in the air compared to the amount of water the air can hold. And so colder air can hold less water, while warmer air can hold more water. So what you'll find here is even if the amount of water in the air stays stagnant, stays the same, as that temperature changes, as air heats up, for example, you might see humidity drop over time. Now, to compensate for that, what I wanted here in my system here was an actual absolute humidity reading here. In other words, I wanted the absolute amount of water in the air at any moment, regardless of temperature. So there actually is a formula to convert from relative to absolute humidity. The problem is it's actually fairly complex here, but this is a great way for us to show off how Dataverse can use a formula column to convert from what I have here to what I want, which of course is my absolute humidity. So I won't go through the formula here. There's a lot of numbers here being thrown around, everything from conversion from Fahrenheit to Celsius and much more. But this basically is the formula used to describe how to go from relative humidity to absolute humidity in Dataverse. So I'll go back here again to my Power Apps, or excuse me, to my Dataverse table. You'll see here, I have a column called absolute humidity. I'll pull it up. And again, this is a formula column where I am telling it to basically, when you serve data to the public through either the API, the app, or otherwise, show data based upon the calculation I have here. So here I'm performing a pretty large calculation, but again, this is just showing that in Dataverse, we're able to not only show static data, but also data which is based upon a calculation of other data. And this is possible in SQL, but the way to achieve it's a bit harder, right? You have to know SQL first and foremost, or maybe more commonly, this could be achieved through your API team in SQL, for example, right? Have your API team, upon data being exposed through the API from SQL, perform manual processes, manual calculations to calculate and retrieve and return this value. Meanwhile, here in Dataverse, it's very easy for us to just simply enter in a new formula column and by hand enter in that formula, hit save, and now wherever we see the data being shown, whether it's Power Apps, the API, or Dataverse, or otherwise, even Power BI for that matter, always include the absolute humidity value. So that's just simply, again, showing how we can go from relative humidity to absolute humidity. So that's how I'm getting this value here in my model-driven app. Now with that done, I want to show you how I'm very easily showing my data in Dataverse in a Power BI report. So I do have here pulled up Power BI, and I'm not really a Power BI expert, but you'll see here in Power BI, being a Microsoft product, natively, naturally, we have a Dataverse connector built into it. So it's not hard at all with data in Dataverse to use Power BI's connector to Dataverse and call in data from any Dataverse environment that you might have. So for me, it was so easy to map it to my Dataverse environment and pull in data. I can show you here as well. Pull in data from my air quality reading table. And my team and I have a large tenant here of a lot of environments, so I can easily find my own TimH prod I'm using right now. And in TimH prod, so it'll pull in here my tables from my Dataverse environment. I can enter in the table name, air quality reading, and just like that, pull in data from Dataverse with only 2 or 3 clicks. With that done, all I did was I added a new column to my data here in Power BI, which is the calculation, just simply to move the created on date, which is UTC time, to my Eastern time here in Florida. So just simply subtract 4 hours from the time to make the data appear in my current time zone of Eastern time. And with that, all I have here is 3 main charts here. I have one for temperature, showing me the trend in temperature in Fahrenheit. One for humidity, showing me trend of water vapor in the air over time. And then one finally for total volatile organic compounds. In other words, the pollutants in the air in my home or outside of my home here for my sensors here, again, against time. With that then done, I saved my report and I published it to an online report that I have. And in the online version of my report, which I'll then go to right now, give me just one moment. Maybe I did have it earlier. Regardless, I'll actually, never mind for right now. I want to show you here in Power Apps how easy it is to embed that into a Canvas app here. In Power BI Online, you can grab the URL of that dashboard in the cloud, and then all you have to do to embed that into a Canvas app here is go to Insert, and there's a Power BI tile control. And then all you have to do is simply modify the tile URL property to the URL of that live report living in Power BI Online. So here I have it, and all I've done is modify one property again, the tile URL, to my embedded report in Power BI Online. Now with that made, I've also done some other stuff as well to my Power App. First of all, at the top right here, I have a refresh button. And upon that being clicked on, what'll happen here is I have some very simple Power FX allowing me to query the most recent air quality reading I have in Dataverse so far. So first of all, I'm performing a sort operation here, asking for all of my AQRs sorted by created on time and descending. So in other words, give me them in order of most recent to least recent. And then I'm grabbing the very first one that I need here to show here, the most recent or the current air quality in my area. Then with that then saved to the most recent AQR variable, I'm then showing that data here in my Power App. So number one, I have here data last collected on, the actual created on time. Temperature, again, showing temperature and also being sure to round that to the nearest whole number as Fahrenheit. The humidity percentage, relative humidity that is, again, rounded to the nearest whole number as a percentage. And then the total or the TVOCs for my most recent AQR here in parts per billion that is. And just below that, I have a small hand here, and the hand is nothing more than an image. And what I'm doing here is I am setting I'm setting the Y property of my hand image here equal to basically what bots it should point to. So I'm saying here, for example, if the AQI is 1, go to 480, which would put it right here. If it's 2, go to 645 right here, 3, 590, 4, 535, 5, 480, etc. And if not, just simply hide that altogether. So that way, when I do refresh my data, it will move that hand based upon what my data is, where my data currently is right now. And I have no idea why it's 5 right now. It's probably inaccurate. I don't know if downstairs right now my wife's cooking or anything like that, but it's possible. So it's odd, but regardless, so that's my Power App, again, showing you how we can very easily embed a Power BI dashboard or Power BI report rather into a Canvas app to track over time air quality. Now I want to show off one more cool thing here, and you might ask yourselves, well, what if we wanted to programmatically call to the system? What if I want to, from either my own application, for example, or perhaps my own website, or perhaps my own system, call to Power Platform to retrieve the current, the most recent air quality readings? And the answer is actually here, you'll see I have my own Power, I have another Power Automate workflow. This one though, it's a bit different. This one again, the trigger here, again, is when it receives an HTTP call. This time though, it's a simple GET request. And this time there's no body whatsoever. So it's just simply an API call, publicly available to anybody, to this URL here. And that URL will then, again, trigger this workflow, which will then in turn perform a Dataverse read operation on my AQR table. I'm then choosing to sort my return operation based on the created on time. Again, descending order. So that way it's being shown to me from most recent to least recent. And I'm choosing to only grab my first item in that array of data. So in other words, just simply pull my most recent AQR that I have right now. And after that, I'm then going to parse that into my own object, just simply so it's easier to pull from later on. And then not only does Power Automate have the HTTP trigger option, but it also has an HTTP response option as well, an action to actually respond to the caller. The key here is in this workflow where my Raspberry Pi calls to Power Automate, if the workflow does not end with an HTTP response, it's simply a trigger. So the Pi will call to it, and right away it'll accept the data and it'll simply respond 200 OK. it worked just fine, and then proceed to move on with its operation. It will not wait for it to complete to return back it worked properly to the requester. Meanwhile, when you call to a workflow which again has that trigger, but it ends in the HTTP response, in that case, Power Automate knows to synchronously perform these operations here, and at the very end, respond with that data or that return object you want to return back to the requester that you have in mind, of course. So again here, what I'm doing here, I have a HTTP trigger for a GET request. I'm pulling the most recent reading from Dataverse. I'm then parsing that, and then I'm constructing the JSON response I want to give back to the user. I want to give back to the requester of the API call. I'm saying here the code should be 200, which of course means okay, it works just fine. Here's your data. And the body I'm plugging in here in JSON sampled for the date and time it was made. It was sampled on the UTC time, that is. Temperature F for temperature in Fahrenheit. Relative humidity. Abs humidity for absolute humidity. AQI, air quality index. TVOC for VOC. ECO2 for carbon dioxide. And I know this is in JSON here. You actually do not need to enter in manually the header of JSON being the type of body of data that's being returned to it. It simply knows based upon the format to do that. So with that done, I want to show you here as well. If I take this endpoint here and I call to it here in Postman, simple GET request, hit send, you'll see here that again, it will call to Power Automate, perform that workflow, and then right away respond back to me with the data. And in fact, I can't put it in the chat because somewhere in there, there's a key right here. But if you go to the system on GitHub, somewhere down here, there's a link to it. You can try it for yourself. Right here, click here to call the endpoint. See, it will just simply return back the data to you. So feel free today to just try that if you want to right now on GitHub. And again, I'm sure based on that, you can think of different possibilities that are possible with that. But for me personally, I have a personal website here, and on that, I choose to showcase some of my projects. And towards the bottom here, I have my current project, my environmental air quality being shown here. But below that, I have a small part of it that shows me live data from my home here in Florida. How is that possible? Well, I'm sure you guessed it. Here is the code behind my website, my actual JavaScript here, where I'm again performing a GET request to that endpoint in Power Automate. I'm then saying to it, if the response was okay, if it worked properly, it's in the 200 range, parse that data in the body. Excuse me. Take that date and time and turn that into a when it was sampled at, how long ago it was sampled at for that matter. And then if the data is less than 1 hour old, show the data. Take the data and show, for example, the temperature, show humidity, show TVOC, ECO2, etc., and everything right there on my website. So now when I refresh, each time I call to it, you'll see here, it'll call the Power Automate and it will return back data, which it should be doing right now, but it's not for some reason. There it went. And it'll show the most recent data as well as as well as when it came from. So that system overall, just having Power Automate serve almost like a makeshift API, we can really easily stand up basically APIs we can call to get data from and embed that anywhere from programs, systems, Power BI reports, or even our own custom web page that might be, of course, to serve the public. And before I wrap today, I love this because by far my favorite thing about this is it is extremely easy to change the schema of how my API responds. I've been used to now for a number of years of using Azure Functions or Azure Web Service to open up my own API system. Each time I change my API, either what it does or how it responds, I have to clone my GitHub repo, open it in VS Code, make my change, save it, push it, maybe do a PR, for example, but also completely redeploy my code to Azure each time. And sometimes, of course, it might not work properly. Most times it does. In Power Automate here with this API system I have here, literally to change what I have here, I have to open up my workflow, go to edit. I can change any part of my workflow from, for example, the way it responds changed. Maybe this, for example, to just sample, not sampled. Hit save, and immediately you will see those effects there on the back end by developers who call to your API system. So it's a very easy way to prototype and change out your API system. So that way, no matter what needs to be changed, from a small bug fix to a larger new feature, for example, it's easy to do here in Power Automate. So with that being said, I'm going to now transition back to our deck. And I think we're going to wrap up there, and we're going to open it up for some questions. So Deb, I'll give it to you I'll give it back to you now for some remarks.
Fantastic. Thank you. I think I've got a couple slides there. If you could move forward, I'm going to stop the recording, and then we can